right, this is the pre-governor school version of the sample test for Unit 9 on equations and systems. And this is the no calculator portion, so be sure you're not using a calculator for this. The first part here is on solving rational equations. So we're going to start out and solve these. We also need to state any restrictions, and we're showing our work. So to find the restrictions, we need to know where the bottom is equal to 0. So I'm going to start by factoring this thing. So I just rewrote that spaced out a little bit, and now I'm trying to factor this denominator right here was the only thing that wasn't factored. So I'm looking for what two things multiply to negative 15 and add to negative 2. So that would be x minus 5 and x plus 3. Okay, so my excluded values are going to be anywhere the denominator would equal 0. So if x were equal to negative 3, the denominator would be 0. That means x cannot equal negative 3. If x were equal to 5, the denominator here would equal 0, so x cannot be equal to 5. Over here in my right equation, I have again, x can't be 5 and x can't be negative 3. All right, so the thing I don't like about this equation is that there are all these fractions. So to get rid of my fractions, I need to get rid of the denominators. I'm going to find the least common denominator for the problem, which would be x plus 3 and x minus 5. Over here, again, I have x minus 5 and x plus 3, so that's my entire least common denominator. To balance, I'm going to multiply this on the left side of the equation, which means I have to multiply it times both of my fractions on the left. When we multiply, we distribute to every single thing. And then I'm also going to multiply it on the right. So remember, for balance, we do the same thing to the left and the right side of the equation. The reason I like to do that is because now I can reduce. My x plus 3's will reduce, and my first fraction is now just 3 times x minus 5. If I distribute, that's 3x minus 15. My second fraction is negative 5 times x plus 3, so that's negative 5x minus 15. Then I had my equal sign. On the right, both of these would reduce out, and all I would have is my x squared minus 6x minus 51. So this is a quadratic equation because it has an x squared in it. To solve a quadratic equation, I like to get everything on one side. Since x squared was positive over here on the right, I'll move everything to the right. On the left, I had 3x minus 5x, which was negative 2x. If I move that negative 2 over to the right, I would do that by adding 2x. So now I would have a total of negative 4x on the right. I also had negative 15 and negative 15, so I had negative 30 on the left. If I move it over to the right, I do that by adding 30, which would give me negative 21. So now I want to factor this thing. I'm looking for what two things multiply to negative 21 and add to negative 4. So that would be 7 times 3 multiplies to 21. If I make the 7 negative and the 3 positive, I will add to a negative 4. Now I'm going to solve this quadratic equation. For my first factor, my solution would be x is equal to 7. For my second factor, my solution would be x is equal to negative 3. I'm ready to write these on the line that says solutions, but I have to remember my restrictions. X was not allowed to equal negative 3, so I have to go back and cross this out. This is a solution. It's one that does not work in my answer. So my only answer that works is the x equals 7. All right, on to number 2. This one is a straight proportion. So I'm looking to solve for x. Again, I need to state any restrictions. So this one's already factored for me. So my denominators would be x plus 1. When I set that equal to 0, x is not going to be equal to negative 1 because that would give me division by 0. X minus 5, when I set that equal to 0, x is not allowed to equal positive 5. So now I would like to set this up by multiplying both sides by the least common denominator. In other words, I'm going to multiply both sides by x plus 1 and x minus 5. This is the same result as if you had done what some of you call cross multiplying, because when I go to reduce here, I have x plus 5 times x minus 5, which if I multiply that out, the difference of squares is x squared minus 25. Over here on the right, I have x plus 2 times x plus 1. I can either do the area model or just multiply it in my head. The middles would go to 3x. and then the ends give me 2. So this looks like it's going to be a quadratic, but when I go to put my x's on the same side, my x squared, sorry, on the same side, they will just cancel each other out. So I'm going to leave my 3x over there on the right, and then I'm going to subtract the 2 to move it over here to the left. So I have negative 27 equals 3x. When I divide both sides by 3, I wind up with x equals negative 9. If I look to see, is that on the bad list? No, it is not a restriction. So my only solution is x equals negative 9. All right. Number 3 has a part A and a part B. It asks me to solve the same equation both graphically and algebraically. So to solve it graphically, I'm going to graph the left side, graph the right side, and see where they cross. So my first thing over here is a rational function. It has a x plus 3 on the bottom, so that has been scooched 3 to the left. And I'm going to have my asymptote has not been moved at all, other than being moved 3 to the left. So I still have asymptotes at y equals 0, and then my vertical asymptote at x equals negative 3. If I were plotting points, my normal shape for this would be to go over 1 up 1, but instead I'm tripling that and going up 3. Normally I'd go over 2 up a half. When I triple a half, I get 3 halves. Normally I have, over 3, is that 3? 1, 2, 3, up 1/3, but when I triple that, it will be up 1. I could keep this pattern going. These numbers are all going to be little fractions as I approach my asymptote right here. I am going to just draw this over here on the left. Normally I'd go 1 to the left and down 1, but instead I'll go down 3. I'll go down 3 halves. I'll go down 3/3 or 1. There we go. All right, now I'm going to graph the right side. The right side is negative x plus 1. That's a line with a slope of 1 and a y-intercept, with a y-intercept of 1 and a slope of negative 1. So my y-intercept is 1, so that looks like a first nice point of intersection. And then I'm going to go up 1, 1 to the left, up 1, 1 to the left. So I have my 2 points of intersection. I could keep this graph going, and it's not going to give me any more solutions. So my 2 solutions are right here at the point 0, 1, and right here at the point negative 2, 3. Now, since the original problem only had x's in it, for my solutions, I only care about the x values. I have x equals negative 2 and x equals 1. 0. I just said the x value, and then I wrote the y value. So. Okay, now we're supposed to solve the same problem algebraically. So I want to first state my restrictions. My only denominator is x plus 3. So I know that if I got x as equal to negative 3 as an answer, I would have to cross that one out because the bottom can't be 0. So I don't like this fraction. In order to get rid of the fraction, I'm going to multiply the left-right sides by x plus 3. So when I do this and I multiply by my x plus 3, I have to make sure I put it to every term. That's the left side. On the right side, I have to put the x plus 3 with both the negative x and with the 1. That's the same thing, by the way, as if I had just put parentheses around this and FOILed it, because that's what FOIL is doing, or the area model, however you like to do it. Okay, so I'm going to reduce over here. So my left side is just 3. On the right, I have negative x squared minus 3x plus 1x plus 3. Again, all I did was distribute, which is the same as if I had FOILed the negative x plus 1 times the x plus 3. All right, so this is a quadratic. I prefer if my quadratic has everything with a positive x squared, so I would move the things over here to the left. So I have x squared. Here I had negative 2x, so when I move it over to the right, it will be positive 2x. And then when I move the 3 over, it will reduce out with the other 3. So I have x squared plus 2x equals 0. So x is my GCF. If I factor that out, I will have x plus 2 as my other factor. So when I solve this, my first factor gives me x equals 0. And my second factor gives me x equals negative 2. I checked to be sure neither one of those is on my restriction list, and they're not. So it looks like x equals 0 and x equals negative 2 are my solutions. Now remember, I just solved the same problem algebraically and graphically, so I should get the same answer. Oh, wait. Look, I did this again. I erased the 0 and I rewrote it. I erased the 1 and rewrote it. So that was 0. Sorry. Again, the coordinates of this point up here was 0, 1. And there's my double check, so I can tell that these two things were equal, and I've just caught my mistake. Great. Okay, let's keep moving. Okay, problem number 4 says two rational functions, f of x and g of x, are graphed. What is the apparent solution to when f of x equals g of x? This is just asking us to solve the equation, and we're solving it by graphing. So I'm looking for where these two things cross. They cross at one spot. All I care about is the x solution. So the solution would be x equals 3. All right, the y value doesn't matter, and I can see they only cross the one time, so that would be my only solution. All right, number 5, circle all the equations that have a solution of x equals -2. So if I have a solution of x equals -2, that means when I plug in x equals -2, this has to make a true equation. So that's how I would check, rather than solve them all, is just plug in and see which ones actually work. All right, so for the first one, I have 2 times -2 plus 6, so that's -4 plus 6 is 2. 2 divided by -2 is -1. What do I have over here on the right? Is that equal to -1? No, that's equal to -2. So this one doesn't work. All right, let's go to the one below it. In this one, when I plug in -2 for x, I'm going to have division by 0, so that one doesn't work, right? I can't have 1 over 0. That's bad. All right, let's try the upper right here. I have 15/7 minus -2 minus 1 over 3. Does that equal 18/7? Okay, so what's this? This is -3 over 3, which is just -1. And it was minus -1. So I have 15/7 plus 1. So that would be 1 I can rewrite as 7/7. 15/7 plus 7/7 is 22/7. That is not the same thing as 18/7, so this one does not work either. I hope the last one works, or I've made a mistake somewhere. All right, so here I'm going to plug in -2 for x. And I need for this to equal 6. So let's see. -2 times 2 is -4, plus 16 is 12. So I have 12 over 3. I don't know why I made that fraction line so long right there. Sorry. 12 over 3 plus 2. So 12 over 3 is 4. 4 plus 2 is 6. So this one works, and that is my only solution, is this one on the lower right. Remember, when it says circle all that apply, you might get more than one answer. You might get one answer you don't know. So you just circle any one that works. All right, now we're on to the second part of the test, which is solving radical equations. So in these, I'm trying to get rid of my square root or my cube root or whatever root I have. So to get rid of a square root, I want to get it by itself. Now both of these square roots were already by themselves. So when I square both sides, the square roots cancel each other out. So I have x minus 5 equals 2x. This is just a plain linear equation. I want to get my x's on the left by subtracting. Move the 5 over to the right. Divide both sides by 5 gives me x equals 1. Now there was no rule, no law for mathematics that says if I square both sides it's always true. So for any of these equations, it's important that I plug back into the original problem and make sure my answer actually works. On the left side, I have the square root of 7 times 1 minus 5. That's the square root of 2. On the right side, I have the square root of 2 times 1. That's also the square root of 2. So this looks like a good answer. I don't have to cross that out or anything. All right, on number 17, this one has a cubed root right here. So the first thing I'm going to do is get the cubed root by itself. So I would divide both sides by 2 to move that over. If this were the square root equals -7, it would not work. But because it's a cubed root's allowed to equal a negative. So to get rid of my cube root, I'm going to cube both sides. So I have x plus 5. Now I've got a cube -7. A negative times a negative times a negative is a negative. And 7 cubed is 343. If you didn't know that, just do some scratch work over here. 7 times 7 is 49. 49 times 7, that's 6. So that's 28, and 6 is 343. All right, now I move the 5 over by subtracting. I get next is x is negative 348. I just circled that, but I really should have plugged in and checked first, so let's double check. The cubed root of 2 times negative 348 plus 5, is that equal to negative 14? Negative 438 plus 5 is negative 343, sorry. The cube root of that would be negative 7, and 2 times negative 7 is negative 14, so this one works. Okay, I'll scoot down just a little bit. All right, number 8. Again, this one has a square root in it. Before I can square both sides, I need to move this 6 over. So I'm going to move the 6 over by subtracting, so I would have 2 minus x. Now I'm ready to get rid of my square root sign. I get rid of that by squaring both sides. So the square root and squared undo each other. On the right, I'd have to FOIL or area model, however you like to do that. 2 squared is 4. In the middles, I would have the negative 2x and the negative 2x, so that is negative 4x together, and then negative x times negative x is positive x squared. So this is a quadratic. I like for it to be equal to 0. This x squared was positive, so I'm going to move my terms over to the right. When I move my x over, it would now be negative 5x, and this was a positive 4. So I'm looking for what two things multiply to positive 4 and add to negative 5. That would be x minus 4 times x minus 1. Then I'm going to set each factor equal to 0. I would get x equals 4 and x equals 1. I do have to check that both of these work. Sometimes one works, sometimes they both work, sometimes neither one. Let's check. I have the square root of 4 plus 6, so that's 2 plus 6, which would be 8. And on the right, I have 8 minus 4, which is 4. So this one looks like it's extraneous right now. Let's plug in 1. I have the square root of 1 plus 6. The square root of 1 is 1, plus 6 is 7. On the right, I have 8 minus 1. And 8 minus 1 is also 7, so this one looks good. X equals 1 is my only answer. I want to be sure that I've circled my answer and then I've crossed out this other one that was extraneous, so there's no confusion. If you wanted to do just like a quick double check of this one graphically, because we did get one that crossed out, I've got a square root that was moved up 6, so that looks like this graphically. I've got a line, if I rewrote that, it would be negative x plus 8. So it's got a y-intercept of 8 and a slope of negative 1. So it's coming like that. They're only going to cross the one time when x equals 1. Okay. All right. On number 9, this 1/2 here is written as an exponent. We need to remember that 1/2 is an exponent. It's the exact same thing as square root. So I'm just going to rewrite that with the square root in it instead. Now I'm going to solve this like any other radical equation. I'm going to get the square root by itself. So the first thing I would do would be to move that 6 over to the other side by addition, and then divide both sides by 2. And I have the square root of 5x equals 15. Now to get rid of the square root, I'm going to square both sides because those are inverses of each other. So I have 5x, 15 times 15 is 225. Then I'm going to divide both sides by 5. And 5 goes into 225. What's that, 45 times? I do need to check my answer. So I have 2 times 5 times 45 to the 1/2 power minus 6. Does that equal 24? 5 times 45. Let's see here. 45 times 5. 225. So I have 2 times the square root of 225 minus 6. Square root of 225 is 15. 15 times 2 is 30. 30 minus 6 is 24. This worked out. X equals 45 is my solution to that equation. So the equation that I just found right there was A. Oops, my pen stopped working. So I will go ahead and circle that. Now I can use this equation to find the y-intercept up above. So if I'm finding this y-intercept, at the y-intercept, the x value is always 0. So I could come in here and I could plug in 0 for this x value. So my y value would be negative the cubed root of negative 6 plus 1. Well, the negative could come out there. So I have the cubed root of 6 plus 1 is my y value. If I wanted to write that exact, it's not a very pretty number, so I wouldn't expect you to do that without a calculator. Okay, if you had a calculator, you could get a decimal version of that. All right, increasing, decreasing. For increasing and decreasing, we have to go from the left to the right. As I go from the left to the right, this is falling the whole time. So it's never increasing. It's only decreasing. It's decreasing everywhere, which is from negative infinity to infinity. Remember, for this we're using the x value, which is negative infinity, and for this we're using the x value, which is positive infinity. So be sure you have these in the right order using the x's, not the y's, because the y's are the opposite of those. Okay. All right, the end behavior. As x approaches infinity, that was this one over here, y was approaching negative infinity because it was down. And over here on the left, as x approaches negative infinity, it was pointing up, so y approaches infinity. And then we already answered the one on the bottom there, so we're ready to move over to the next page. All right, now we've switched to the calculator active part. I'm not really going to use a calculator pretty much for the rest of this, but you could use a calculator if you wanted to check your answers. This says mark an X on any of the solutions to the following system of equations. The solutions are the two places where they cross, so I'm just going to mark an X on those two spots. If it says X, I put an X, not a circle or a dot. I do exactly what it says. All right, so that's it. Number 17, this is the portion of a graph of a system, which is most likely the solution set. So again, the solutions are the two locations where these two things cross. This looks like a nice point here, 2, 2. This is also a nice point. It's -2, -2. So looking at my answer choices, that is answer choice C. All right. The distractors here are that we don't want the x-intercepts or the y-intercepts. We only want where the two graphs cross each other. All right, let's turn over to the next page. Number 18 asks which of the following is not a solution to. So if something is not a solution, it means that when I plug it in, it will not work, okay? One or both of the equations will be false. So for this one, I could either, come up with a little sketch and see which one seems reasonable, or I could plug in and guess and check. I'll do both of those for you. So I'm going to start out by plugging in, guessing and check. So the first one I'm going to plug in is A, 0, 10. So for A, plugging in 0, 10, that means into my top equation here, I'm going to plug in 0 for x and 10 for y. So I would have 0 squared plus 2 times 10 minus 20. Does that equal 0? So this is 0 plus 20 minus 20 equals 0. That's true. Then I'm going to plug in xy in the bottom equation here. So I have 0 squared plus 10 squared. Does that equal 100? Yes. So A is a solution, which means A is not the correct answer because I want what's not a solution. All right, now I'm going to try B. For B, the point I had was -6, -8. So if I plug in x is -6, I have -6 squared plus 2 times -8 goes in for y. So up here I have 36 minus 16 minus 20. Does that equal 0? Yes, it does. So that one looks good. Then I'm going to plug in -6 squared plus -8 squared. I'm plugging into the bottom equation. Does that equal 100? 36 plus 64 is 100. So that means B is a solution. So I don't want that one either. Let's try C. In C, I'm plugging in -6, 8. So this time I'm plugging in -6 for x. I'm plugging in 8 for y. So for this one, I have 36 plus 16 minus 20 equals 0. No, this is 50. No, doesn't work. So that means C is the correct answer. It is not a solution. Just to verify, let's go ahead and plug in D as well. If I plug in 6, negative 8, 6 squared plus 2 times negative 8 minus 20 equals 0. So this is 36 minus 16 minus 20 equals 0. That's good. And then in the bottom equation, 6 squared plus negative 8 squared, does that equal 100? 36 plus 64 is 100. That one's good. And D is also not a solution. Okay, if I were going to think about what the graph of this looks like, just a very quick little sketch. My top equation is going to be a parabola because it has an x that's squared but not a y that's squared, so I'd need to do some rearranging here. I would move the x squared to the other side, so it'll be a negative x squared. I would move the 20 to the other side, so it'll be a plus 20. Then I would divide everybody by 2, so I'd have negative 1/2 x squared plus 10. So this is a parabola that's been moved up 10. It's been flipped over and kind of smooshed out a little bit, but regardless, it looks something like that. Okay. This bottom equation is a circle. The center is at the origin because the x and y have not had anything added to them, and the radius is 10. Remember, I was up here at 10 for this point, so when I go like this and make my circle, it looks like I should have 3 answers. This answer up here was 0, 10, which was answer choice A. This one down here would be negative 6, negative 8, which is answer choice B. And this one down here is going to be the positive 6 and negative 8, which was answer choice D. So C at negative 6, 8. Negative 6, 8. There's not going to be any solution up here in this second quadrant. That was my bad answer. All right. Number 19 asks you to identify the x and y coordinate of each point that is a solution set of the system of equations. So sometimes they ask us for either the x or the y. Make sure you pay attention if they ask for only one, that you're giving the correct one that they're asking for. Again, I'm going to try to do this without my calculator. So I would like to get rid of one of these letters. If I wanted to do elimination on this, I could. If I multiply this bottom equation times 3, so my top equation, what I need to eliminate are the y's, because I can't eliminate this x squared and the x. So if I'm going to eliminate these y's down here, I need this to be a 3y, because it's subtract, then I'll have plus 3y minus 3y. So if I want to multiply this whole thing through by 3, that would give me 9x minus 3y minus 18 equals 0. So let me pause and rewrite this first. Okay, so I can now add these two equations together. If I do that, I don't have any x squareds to put together, so I still have negative 6x squared. 24x plus 9x is 33x. 3y and minus 3y is 0. That's what I've done. I've eliminated them. And then negative 9 and negative 18 is negative 27. 0 and 0 is 0. So I don't like this being negative right here. I also notice that all of mine are multiples of 3. So I'm going to go ahead and factor out a negative 3 as the GCF. So if I factor a negative 3 out of this, it would be 2x squared. Factor a negative 3 out of this, it would become, whoops, not a positive 11, but now a negative 11 because I'm going to switch signs when I factor out the negative. Negative 27 divided by negative 3 is positive 9. So now I've got this negative 3 that I'm going to kind of leave out in front for a second, and now I'm trying to factor this one. I'm hoping that it really factors. So for this one, since this has a leading coefficient, I usually go ahead and I go to the area model. So I have 2x squared, and I have positive 9. So I'm looking for what two things multiply to 18x squared and add to negative 11. So I can multiply to 18 by doing 9 times 2. And, oh, sorry, my board is not doing well here. Keeps freezing up on me. Okay, hopefully it will be better now. It keeps coming back to my thinking. So this is going to be negative 2x and negative 9x because to multiply to a positive, I need a negative times a negative. These will multiply to positive 18 and add to negative 11. So my GCF over here is 2x. 2x times x gives me 2x squared. Negative 1 times 2x is negative 2x. Negative 9 times x is negative 9x. Negative 9 times negative 1 is positive 9. So my two factors over here were 2x minus 9 and x minus 1. When I set each of those factors equal to 0, I get x equals 9/2 and x equals 1. So looking over here, x equals 1. And then 4.5 is 9/2. I think I probably would have left that as a fraction. So I'll just write both. Okay, it did ask me for both the x and the y coordinates, so I'm going to have to plug in 9/2. I can plug into either equation, but what I really want to plug into is this second equation, because that one didn't have the same exponents as the top one did. If I plug into the top one, I might get more than one answer. So I'm going to plug in x is 9/2. And then I'm going to solve this. So 9/2 times 3 would be 27/2. I will move the y over to the right side. I have 27/2 minus 6. 6 is 12/2. So let me just change that right here. Okay, I'm going to change that to a minus 12/2. Might as well get a common denominator at one time. So that is 15/2. So remember, if I were writing this as an ordered pair, my x would be 9/2 and my y would be 15/2. If I'm just listing the x and y coordinates, 15/2 is 7.5. Again, I like the fraction better. So that's 7.5. Sorry, this is my work for x. And then I also have to plug in my x is 1. It's going to be a little nicer to plug in. And in that one, I have 3 minus 6 is negative 3. So I get y is negative 3 as my other answer. And it's up here. So all the box answers up here are doing for us is making sure if we made a careless mistake that that answer would not have showed up. I will go ahead and pop this one up on a calculator so that we can see that our answer also worked. If it didn't ask for any work, I could have just jumped right to my calculator. Let me clear out what's in here. So my first equation, if I got y by itself in this equation so that I could graph it, I would be moving everything over to the right-hand side. So I'm just going to start with a parenthesis. I would be moving the 6 over by adding it. Then I would be moving the 24x over by subtracting it. Then I would be moving the 9 over by adding it. And then all that stuff would have been divided by 3, which was my coefficient of my y. For my second equation, if I got my y by itself there, I probably would have just brought this y over to the right by adding it, and y would be 3x minus 6. Okay, I am going to do a standard window. And my line and my parabola cross 2 times. If I go to calc the intersection, I move close to where they cross. I hit enter for the first curve, second curve, and the guess. And it says 1, -3, which was one of the answers I came up with. Then I have to repeat the process for the second curve. So I calculate the intersection. I move close to where they cross. I hit enter, 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 and I get 4.57.5. So read the directions. I might ask you to solve algebraically or graphically. You have to be able to do both. All right. I think we're getting closer to the end here for the regular work. All right, number 20, solve the system, show the work algebraically, and confirm graphically. So in this one, my equations are nicely set up to do some eliminating right now. I would want to do a subtraction because I need to eliminate y, or I could do the same thing as doing a substitution, which would just be when does the right side of each equation equal each other. Same thing. Y minus y is 0. x squared minus negative x squared is positive 2x squared. Negative 8x minus, there weren't any, so that's just negative 8x. Negative 16 minus negative 6 is the same as negative 16 plus 6. Probably would have been easier to just go ahead and change them all along. All right, now I want to factor. I can take a 2 out as a GCF. What two things? Multiply to negative 5 and add to negative 4. That's x minus 5 and x plus 1. Set each factor equal to 0. Gives me x equals 5 and x equals negative 1. I'm going to go ahead and plug in. Doesn't really matter which equation I plug into. I think this bottom equation would be the easier one to plug into. That's why I probably shouldn't have put those negatives on there. So if I'm going to start out by plugging in x equals 5, I would have y equals negative of 5 squared minus 6. So y is negative 25 minus 6 gives me y is negative 31. So my first point is 5 comma negative 31. Then my second intersection point was x equals negative 1. When I plug that in, the opposite of negative 1 squared. So when I square, I get positive 1, but now I multiply by negative. So I get y is negative 7. So I have negative 1, negative 7 is that point of intersection. If I need to confirm this graphically, I can put them both in my calculator. So I go back to my y equals, clear these guys out. I have x squared minus 8x minus 16. And then my second equation was negative x squared minus 6. Oops, I missed my negative over there. Hold on. Insert that little negative down there. Oh, it's not. There it goes. Okay. So first I'm graphing it in a nice standard window. And when I do that, I know I should be getting two solutions. And this negative 31 was pretty little, and this is crossing down here. So I'm probably just going to zoom out. I go to zoom out. When I'm zooming out, I'm going to scoot down a little before I hit enter. You don't have to do that, but it just zooms with the center a little closer to what you need. Okay, so I can see my two solutions right here. So I go to second, calc the intersect, move close to where they cross. Whoops. And hit enter, enter, enter. And there's my first intersection is negative 1, negative 7. And then I repeat the process. I move over to close to where they cross. I hit enter, enter, enter. And my second intersection is 5, negative 31. If you were doing this on your graph paper or on your test paper, you could do just a little sketch would be fine. So we had like this, and where they crossed was 5, negative 31, and negative 1, negative 7. Good. Okay, on to the applications. Number 21 says a plumber and his assistant finished a job in 4 hours. So when they worked together, they took 4 hours. The job would have taken the plumber 6 hours if he were working alone. How long would the job have taken the assistant if he were working alone? Okay, so what we like to do for these is we like to come up with our rate. So for the plumber, what does the plumber do? The plumber would do the job in 6 hours if he were working alone. So the plumber does one job every 6 hours. Okay, or he does 1/6 the job every hour. Now together, the plumber and assistant do the job in 4 hours. So together, we have one job in 4 hours. All right, and what we're looking for is what the assistant can do. So the assistant does one job in X hours. So how could we figure this out? Well, what the assistant will do, right? If we have the assistant plus the plumber, that's them working together, or it's them working together, take away the plumber working, same thing. So 1 over x is 1/4 minus 1/6. I could do the fractions just by getting a common denominator, but in case I make a mistake, I'm just going to go ahead and do them in my calculator. 1/4 minus 1/6. I go math to the right and up. So I have 1/4 minus math to the right and up, 1/6. So I get 1/12. So 1 over x is equal to 1 over 12. So if I just take the reciprocal of both of those, I have x equals 12. Remember that I'm supposed to give any answer as a sentence with units. So let me write that out. Okay, so alone the assistant takes 12 hours to do the job. This seems like a reasonable amount of time. The assistant should take longer than the plumber, and the plumber took 6 hours. So looks good. Okay, let's turn the page. We have a